A submarine at 600 meters faces 60 atmospheres of pressure. A window the size of a dinner plate would need to withstand 18 tons of force. So they don't use windows. They use sonar, photonics masts, and periscopes. Here's why glass would literally kill them. Water weighs 1,025 kilograms per cubic meter. At 600 meters, you're supporting a column of water weighing 600 tons per square meter. But the real killer isn't the glass breaking, it's the seam. Where glass meets metal, you create a stress concentration point. Under pressure, the steel hull compresses and shrinks. The glass doesn't. The window pops inward like a cork. That's not a leak. That's instant death. So how do you navigate a billion-dollar machine through underwater mountains at 30 knots without looking outside? 3 ways. Passive sonar that hears enemy engines 100 kilometers away. Photonics masts. Cameras on telescopes that poke above the surface. And when they absolutely need to see, research subs use acrylic windows that deform under pressure, sealing tighter as they go deeper. But for combat, no windows, no weakness, just a perfect steel tube. For every 10 meters of depth, the pressure increases by 1 atmosphere, or roughly 14.7 pounds per square inch. By the time a Los Angeles-class submarine reaches its test depth, the pressure on the hull is equivalent to an elephant standing on a postage stamp, multiplied across every inch of the ship. To survive this, the hull cannot have soft spots. In engineering, a window is a discontinuity. Even if the glass is strong enough, the seam where the glass meets the metal creates a stress concentration point. Under 60 atmospheres of pressure, the hull actually compresses and shrinks by several centimeters. If the metal shrinks, but the glass doesn't at the same rate, the window would simply pop inward like a cork. This is why combat submarines are built as perfect cylinders of HY-80 steel. HY-80 stands for high-yield steel, capable of withstanding 80,000 pounds of pressure per square inch before it permanently deforms. But even this steel has a limit. When a hull fails, it doesn't leak. It implodes. The air inside the submarine is compressed so fast by the incoming water that the temperature can briefly reach that of the surface of the sun. The entire 300-foot vessel is crushed into a mangled ball of metal in less than a fraction of a second. This is why engineers prioritize a clean hull. Any opening, even for a periscope, must be reinforced with massive steel bosses to redistribute the load. Some nations, like Russia, have experimented with titanium alloys for their hulls. Titanium is stronger and lighter than steel, allowing ships like the Alpha class to dive even deeper, potentially reaching 800 meters. However, titanium is incredibly difficult to weld. Any impurity in the welding process creates a microscopic crack that the ocean pressure will find and exploit. But whether it's steel or titanium, the goal is a monocoque structure, a single, unbroken pressure vessel. The hull is further obscured by anechoic tiles. These are rubberized blocks glued to the outside of the steel hull. These tiles serve 2 purposes. They absorb the ping of enemy sonar, and they dampen the noise coming from inside the sub. A window would break this acoustic seal, making the submarine glow like a lighthouse on enemy sonar screens. So how does a crew navigate a billion-dollar machine through a mountain range at 30 knots without looking out a window? They use sonar or sound navigation and ranging. In the deep ocean, light is useless, but sound travels 4 times faster than it does in air. Passive sonar is the submarine's primary eye. It consists of incredibly sensitive hydrophones that listen for the signature of other ships. A skilled sonar technician can see a vessel hundreds of kilometers away just by the frequency of its engine vibrations. They also have to account for the Alford effect, where different layers of water temperature and salinity act as mirrors for sound. A submarine can hide under a thermal layer, where sonar pings from the surface simply bounce off, making the sub invisible even without windows. For visual confirmation near the surface, submarines don't use traditional windows in the hull. Modern boats use photonics masts instead of traditional optical periscopes. These are high-definition, low-light camera arrays that extend above the water and beam a digital signal down to the control room. This allows the bridge of the submarine to be located deep within the protected center of the ship rather than directly under the sail. However, there is one major exception to the no windows rule: deep research submersibles. Vessels like the Alvin or the James Cameron Deep-Sea Challenger have viewports, but they aren't made of glass. They use optical-grade acrylic. Unlike glass, acrylic is slightly flexible. Under extreme pressure, an acrylic window actually deforms and seats itself tighter into its conical metal frame. The windows are shaped like truncated cones, so the ocean pressure pushes the window into the hole, creating a tighter seal as the ship goes deeper. For a research sub to go to the bottom of the Mariana Trench, 11,000 meters down, the window might be 20 centimeters thick for an opening only 10 centimeters wide. But for a combat submarine, that level of thickness is impossible. A window thick enough to survive the depth would be too heavy and would ruin the sonar-absorbing stealth coating of the hull. In the silent service, survival depends on being a perfect, seamless tube of high-strength alloy. But as materials science advances, the limits are being pushed. We are now seeing the development of transparent ceramics and synthetic sapphire panels that are nearly as hard as diamond. This raises an interesting question for the future of naval architecture. If we could build a material that is as strong as HY80 steel but as clear as glass, would we? Or has the age of digital sensors and AI-assisted sonar made the human eye obsolete in the deep? If we could build a hull entirely out of transparent aluminum, how deep could we theoretically go before the light of the sun and the structural integrity of the ship disappeared forever?